Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. In this video, we're going to finally dive into the first formula for the F statistic now that we finally understood what the F test is actually testing. Keep in mind, nothing new conceptually is going to come into this video. We're just putting the symbols and all of the numbers that we've seen so far in the regression output together. Okay, so keep in mind, everything started from one key identity, which was that the total sum of squares is equal to the explained sum of squares plus the residual sum of squares. The F-test compares two things: how much variation the model explains and how much variation is left unexplained. But keep in mind, it doesn't compare them raw, it just compares average explained variation to average unexplained variation. Explained variation depends on how many regressors we include. So number of regressors. And whether obviously they are good regressors. Unexplained variation, which is what is left in your residual sum of squares, is that depends on how much data we have. And what will happen to keep the comparison fair, because we said compares average explained variation to average unexplained variation, with average being the keyword in here. So it means, like, to make this comparison fair, we need to scale the explained sum of squares by the number of the regressors and the residual sum of squares by the remaining degrees of freedom. Based on that, the formula for the F-test that we are going to first write is this is equal to the explained sum of squares divided by k, meaning the number of your regressors, divided by the residual sum of squares divided by n minus k minus 1. N, as usual, is like the total number of observations that we have in our sample. So it's literally your sample size. So in a sense, this ratio is explained variation per regressor divided by unexplained variation per degree of freedom. If the model explains a lot of the variation per regressor and leaves little variation per degree of freedom, the F statistic obviously will be large. And that makes the null hypothesis, which was all slopes are zero, hard to believe. Instead, a small F statistic means that the model barely improves on that benchmark mean. These numbers are what you indirectly see basically in that left corner block that we had in this data output. So if you remember from the previous regression that we had, when we introduced the variation, we mainly talked about this part of this block. So these degrees of freedom are based on the number of the regressors that you had included. And in our model, we had included 3 variables. And then the total here, the 73, was based on the number of observations that we had in that sample. So it means that the leftover degrees of freedom here is this 70, the n minus k minus 1. So 74 minus 3 minus 1. The ms that you see here, the mean squares, now you can calculate it yourself and you can double check where it's coming from. So the mean squared in here is going to be your explained sum of squares divided by that k, while for the RSS, you can divide that by n minus k minus 1, which is this degree of freedom of 70 that you have in here. Okay, and keep in mind for the total, the degrees of freedom will be the n minus 1. Okay. At this stage, we're not going to see yet how we interpret and how we do the F statistic. I just wanted to introduce you the one of the few formulas that are used for the F statistic. In the next video, we'll write the same F statistic but using the R squared instead of the sum of squares, so different formula, same test. But depending on the material and the book that your lectures are based on, you might see either or the other. So it's better to know all of them and be introduced to all of them so that you can then pick which is the one that you will be using forward. So stay tuned and I'll see you in the next video.